Okay, so this lesson objective, we're going to be explaining the dollar value LIFO method. So the dollar value LIFO method overcomes the problems of redefining pools and eroding layers. The dollar value method determines and measures any increases and decreases in a pool in terms of dollar value and not the physical quantity of goods in the inventory pool. The advantages of the dollar value approach, the advantages over the specific pooled goods approach are that first, companies may include a broader range of inventory. A broader range of inventory in a more condensed pool, like a smaller type of a pool. Well, in a dollar LIFO pool. Second, a dollar LIFO permits replacement of similar items or similar goods and items, similar in use or interchangeable. Dollar value techniques help protect LIFO layers from erosion. Under the dollar value LIFO method, one single layer may contain the entire pool. The more goods included in the pool, the more likely that increases of some of the goods will offset decreases in other goods in the same pool. Hence, companies avoid liquidation of LIFO layers. Having fewer layers means less cost and less chance of erosion. Okay, so now dollar value LIFO example. So assume that Enrico first adopts dollar value LIFO on December 31st, 2011. The inventory at current prices on that date was 20,000. But then now the inventory on a year later, on December 31st, 2012, has a price. Again, we're just doing value, 26,400. We're not really looking at item number. Can we conclude that Enrico's inventory quantity has increased by 32% during the year? Yeah, absolutely. So we're looking at it in terms of the end of one year and the end of another year. However, there could in fact be a change from the beginning of the 2012 year, and that change we have to also quantify to see how things then how the percentage changed between the actual beginning of the year and the actual end of the year. So there are multiple points in time. There's end of year, there's beginning of the year, and then there's end of year. So in this case, we're just looking at the two end of year values. Can we conclude that Enrico's inventory quantities increased 32% during the year? And this value is correct. And what is the value of the ending inventory in terms of the beginning of the year prices? So now we're looking at the beginning of the year prices, and we're looking at inventory in terms of beginning of the year prices, and we do things using indices and or percentage change. All an indice is really doing is a percentage change. You take the 26,400 over that initial 20,000, and in this case we have 26,400 over 120%, which is going to give me that yearly change percent of 20%. Prices increased 20% during the year. So if I know these are different, then I know the beginning inventory point was different than the ending inventory point of the prior year. So it's not consistent. It wasn't the ending percentage equated to the beginning percentage. So prices increased a certain amount during the year. In this case, it's 20%. Therefore, the inventory quantities increased only 10%, or from 20,000 to 22,000 in terms of the beginning of the year prices. The real dollar quantity increases 2,000. Valued at year-end prices is 120% times 2,000. So we have an increase of 2,000. You go from 20,000 which was the end of the year, of the prior year, then right straight to that next beginning of the year, you have 22,000. So we have a $2,000 change or increase. And if we do that off of the base year percentage, we multiply it by 120% increase. So now we can translate that into the current base year. You're essentially looking at indices and translating them into what it would look like in that year, what the value would look like within that year, based off of percentage changes of increase and decrease. So it's really a translation exercise. We're translating it by multiplying it by the indice. So the first layer, beginning inventory, in terms of 100 will be 20,000. The second year 2012 increase in terms of 120 will be 2,400. As we said, the dollar LIFO inventory in December is 22,400, which we discussed. So all this has been discussed. Here's our 2,400. Here's a 20,000, and well, we add these together, obviously. So note that a layer forms only when the ending inventory at the prior, I'm sorry, at the current layer exceeds the beginning inventory at the prior layer. And that is true, but they use base year layer exceeds the beginning inventory at the base year prices. So just keep that in mind. But if we're going through this, we have the base year, but this is a value that's going to be the like the current asset value. This is an indice, and this is a ending inventory in terms of base year pricing. This is just the ending inventory, basically. So these are priced differently, slightly differently, and they differ. We translate it from the ending inventory at year-end prices to the ending inventory at base year prices, and we've established that base year by using an indice, which will tell us a percent change. And as we'll see later on, one confusing aspect is these aren't really necessarily calculated by anyone. You can just almost use set indices and then implement them in your problem solving. December 31st, 2009, computes the ending inventory under dollar life of value as 200,000 as shown below. So now we're just giving you an example. We're taking this specific line. We know the ending inventory at the base year price, the layer at the base year price, so we multiply it by this indice. So now I get the ending inventory price for LIFO costs. So a comparison of the ending inventory at base year prices with beginning inventory prices indicates that the quantity of goods increased. So we have a $60,000 increase. We take the 260,000 minus the 200,000, so we have a $60,000 increase. And that $60,000 increase, we can then apply that same percentage. So we're taking our base here, we're taking the percentage of that change between the 2 years, between the base and 2010 year, which I have right over here, here, we're looking at just the base year differences, percentage changes. And I take my base year difference or change and multiply it by my indice, and then I get an ending inventory at LIFO cost. So a company must subtract the decrease from the prior year. So there's a decrease if there's a net negative value, or net change that's negative, you subtract it from the prior year. So I have a negative change from going from 260,000 to 250,000. So I'm going to take that change and I'm going to subtract it from this layer multiplied by this percentage. And essentially you're just peeling off previous layers, prices, and existence when it added layers. So a comparison of the ending inventory at base prices, 250,000, the beginning inventory at base year prices, 260,000, indicates a decrease in the layer of 10,000s. In Bismarck's situation, this means that it removes 10,000 in base year prices from 2010, from the 2010 layer of 60,000 at base year prices. So it values the balance at 50,000. Again, we just go back to that layer and we subtract out the 10,000 that we've already established. And it values the balance of the 50,000 at base year prices of the 2010 index of 115. As a result, it now values this 2010 layer at 57,500, and you're just multiplying 50,000 times 115. And Bismarck computes the ending inventory at, so it's going to be just adding these two together. So it's 257,500, consisting of the beginning inventory of 200,000 and a second layer of 57,500. At December 31st, 2012, a comparison of the ending inventory at base year prices with the beginning inventory at base year prices indicates an increase in the quantity of goods in base year prices of 20,000. So now I have an increase of 20,000. After converting the 20,000 increase using the 2012 price index, the ending inventory is, so I'm going to go to that 2012 index, I'm going to multiply it by 130, I end up with 26,000 composed of the beginning layer of, the entire total, after converting the 20,000 increase, so you convert it to 26,000, the ending inventory now is 283,500. So that's really it. Price changes are critical in dollar value. LIFO, the most popular general external price level index, is the consumer price index for urban consumers. Various organizations compute and publish daily indices of most gold, silver, other metals, corn, wheat, and other farm products. Many trade associations prepare indices for specific product lines or industries. Any of these indexes may be used for dollar value LIFO. A company may compute its own specific internal index, and a company may choose to compute its own specific internal index, which would ordinarily determine current costs by referring to the actual cost of goods it most recently had purchased. So here's an example of that. It's a double entry method. So you have ending inventory for the period at current costs, ending inventory for the period at base year cost. Double entry is incorrect. It's double extension method. And you can have quantities, cost per units, you get the total cost. Examination of the ending inventory indicates that the company holds. So I'm going to go to this table over here, and I'm going to see we have 3,000 units of item A and 6,000 units of item B on December 21st, 2012. The most recent actual purchases related to these items were as follows. So here's your purchase date, and here's the quantity, and here's the cost per units. So this is kind of a purchasing table. And over here, we have the price per units, ending price per unit. This is the base price per units. I'm sorry, I had this reversed. This is the base year cost per unit, and this is the current year cost per units. So I have both of these, and I can once again compute an indice now because I have the base versus the current, and I can go ahead and do a percentage change, and now I have what is basically a manually calculated indice. So Toledo then applies this 121.74% index. Whichever cost load assumption is adopted, a company must use it consistently from one period to another. Note in this illustration that Toledo uses the most recent actual purchases to determine current cost. That's an interesting point because we have a table of purchases, and then we're also told that the ending inventory indicates the company holds 3,000 and 6,000, and we have B is at 5,000, so we use 5,000, and in this case we use 3,000 and 1,000 for the actual costs per unit, or current year cost per unit. So use of the double extension method is time consuming and difficult, where technological change has occurred or where many items are involved. 3 different approaches to LIFO inventories in this chapter. There's a specific goods LIFO method, specific goods pooled LIFO method, and dollar value method. Use of the specific goods LIFO is unrealistic. Most companies have numerous goods in inventory at the end of the period. Costing them on a unit basis is extremely expensive and time consuming. The specific goods pool reduces record keeping and clerical work. It is also more difficult to erode layers because the reduction of one quantity in the pool may be offset by an increase in another. So you have that change. Most companies using LIFO system employ dollar value LIFO. However, problems exist with dollar value LIFO. The selection of items to put in a pool can be subjective. Manipulation of the items in a pool without conceptual justification can affect reported value, can affect reported net income, excuse me. The SEC noted that some companies have set up pools that are easy to liquidate. To increase income, a company decreases inventory, thereby matching low-cost inventory items to current revenues. Okay, so that is it for lesson objective 8. Thank you.